Alright, so what I'm going to do right now is put a little bit of water in the pan. This is just water, I promise you. There's nothing special about it. We just have it in here so the pan doesn't get really hot and boil the heptane when we pour it in. So what are the three parts of the fire triangle? Just yell them out. Heat. Fuel. Oxygen. Alright, so what we have here in the room right now, we have oxygen, obviously, because we're all breathing it, hopefully. What's next is heptane. Heptane is going to be our fuel in this case. Heptane is a lot like gasoline. So we have our fuel now. So this is what we're going to be burning as our fuel. A little bit more. And so here's our fuel. We have oxygen, and the last thing we need is what? Heat. All right. The heat source we're going to provide is by using a match. Let me grab that real quick. All right. So what's going to happen is, once I light this, it's going to be a regular flame. You guys seen regular flame? It burns like a shape of a cone, upside down ice cream cone. This is what's going to happen is this is going to burn all the oxygen in this room. And then we have you see the walls in this room, right? These openings, they're placed in a very specific way to provide a specific airflow that we want. So I'll let you guys take a look. Over here. So, how was that? I just heard someone say they want to switch majors. So, what was one of the first things you guys noticed about that?
It was hot.
It got really hot, right? Initially, it wasn't that bad, and then as soon as it started spinning, it got real hot. And you saw how tall it was, right? It was about 1 meter tall. That grew from 1 meter, which is about 3 feet, up to 15 feet tall, 5 meters. And it got really hot. So what happened is, it was burning the fuel at about twice the rate that it was initially before it started spinning. So it's going to give off about twice as much heat, which is why you guys felt how hot it was. And so that's what basically happened. It burned all the oxygen in the room initially, and it started pulling in more oxygen, which created that flow pattern to create that tornado. How many of you guys think this happens in nature, just naturally? So we got almost everyone. Yeah. How many of you guys think this just happens like Jason, or Michael Bay, whatever? He throws this together and makes up a giant tornado, and he's like, oh, let's throw a fire in it. This is actually a naturally occurring phenomenon. This happens primarily in wildfires, where it happens, you see how these walls are designed in this way? Imagine those walls are trees. So you have that same exact flow pattern creating that wind effect. And then you saw how the fire didn't really move out of that pan, right? That's because we have a very controlled fire here, as opposed to where it can happen out in nature. Where you think about it, you got leaves, you got branches, you got all this stuff all over the ground. That's all fuel. That's all going to keep fueling that fire. And so in nature, that fire is going to start moving, and it's going to be extremely dangerous out there. What you guys really can't, what we really couldn't do here is something that happens out there is something called fire brands. those are going to be little pieces of debris that fly out of that tornado. So imagine that fire is just going to be burning there. You're going to have little twigs and stuff lit on fire, thrown hundreds of feet away, causing fires over there now. Now you guys can kind of get a feel for how extremely dangerous these things can be, which is one of the reasons we study it, because we want to prevent these things from occurring in nature. But what happens is these can also occur in human environments. So imagine these walls are now buildings. Same exact scenario. You got that flow pattern, you have wind, and you have that fire tornado. The most notable event, most notable fire tornado that we have on record is the Kanto earthquake in Japan in 1923. You guys are thinking, how does an earthquake cause a fire? 1923, you're going to have people cooking with open fires, as opposed to electric cooktops and whatnot. That earthquake's going to start knocking everything over, cause all these fires. And what happened was a whole bunch of people, about 40,000 people, evacuated to a safe area, what they believed was a safe area, which was a clothing depot. And this clothing depot was a gigantic warehouse. What happened was the fire actually spread to that area and caused a fire tornado inside that building and killed 40,000 people. And so we as fire protection engineers study this so we can prevent these things from happening in nature and in man-made environments. Because as you can tell, it's extremely dangerous. So, any questions about fire tornadoes or our department?
How long have you been there before you did that?
So I am a junior right now. I actually worked Maryland Day last year as well, but I was out stuck in the hallway. So, about a year. Any other questions? So our next demo is our sprinkler lab. Sprinklers are one of the primary ways we prevent fires and put out fires in buildings. And so they're going to show you how those work and explain a little bit about that.